Hello, hello, hello. Okay, right. So, while loops. Now, to totally blow your mind with a new loop, the while loop, a while loop will keep executing the code block under it as long as a boolean expression is true. Wait, you have been keeping up with this terminology, right? That if we write a line and end it with a colon, then that tells Python to start a new block of code. Then we indent, and that's the new code. This is all about structuring your program so that Python knows what you mean. If you do not get the idea, then go back and do the same work with if statements, functions, if statements, functions, and the for loop until you get it. Later on, we'll have some exercises that will train your brain to read these structures, similar to how we burned Boolean expressions into your brain. Okay, back to while loops. What they do is simply do a test like an if statement, but instead of running the code only once, they jump back to the top where the while is and repeat. The while loop runs until the expression is false. Here's a problem with while loops. Sometimes they do not stop. This is great if your intention is to just keep looping until the end of universe. Otherwise, you almost always want your loops to end eventually. To avoid making these problems, there are some rules to loops. There are some rules to follow. Make sure that you use while loops sparingly. Usually, a for loop is better. Review again. Review for while statements. Review your while statements and make sure that the boolean test will become false at some point. When in doubt, print out your test variable at the top and bottom of the while loop to see what you're doing. Okay. So we have this number, we at the top and we append it and then we print numbers. Okay, so this will be 1 2 3 4 5 6 at the bottom, right? 0 1 2 3, we have numbers 0. Oh, because we appended I. Okay, okay, so we are okay, 0 to 5, right? And then we print those numbers too. Okay, great. So we'll create while loops, right? While loops, then we can create file 33.py, and here we can create, okay, so we have a, then we have a list, then loop while I is less than 6, we say we print out the variable at the top. Okay, at the top I is, there we go. Sorry, but okay, print at the top I is I. Okay, then within numbers we will append I, then we go, okay, then we increment the loop, right? I equals I plus 1, then we print numbers now, numbers now, numbers now, so we'll get numbers, and then finally, and okay, then we print I at the bottom. Okay, at the bottom I is, okay, then we print the numbers, then we print them with a for loop. We go num in numbers, I want to print num, right? Yeah. Alright. So we run this. Then we go here. Okay. Schedulers convert the while loop to a function that you can call and replace 6 in the test I less than 6 with a variable. Okay. Use this function to rewrite the script to try different numbers. Okay. Add another variable to the function argument that you can pass in. So let's say change the plus 1. Oh, increment. Okay. On line 8, so you can change how much it increments by. Rewrite the script again to use this function to see what effect that has. Write it to use for loop in range. Do you need the incrementer in the middle anymore? Okay, what happens if you do not get rid of it? Do you need the incrementer in the middle of it? Okay. If at any time you're doing this, it goes crazy, probably well, just hold down Control C and press C and program will abort. Okay. Yeah, well, I can try this. Let's write a function. So above this, yeah, loop through. We take in variable, let's say size. Then we take in step, right? Okay. So we can go. That is the step. So for I in range, size step, I think this will, okay, this will go. I'm going to define size and then, okay, hold up. By dog and I want to range. Okay, so we have start, we have a stop, and then we have a step. I am not sure about, should there be a bracket here? Okay, I mean says, it says the size, then there's no comma, and then step. Okay, so let's print I, right? Okay, let's remove these guys for a while, and let's just call this loop through. Invalid syntax. Okay, so invalid syntax. Okay, maybe I can say step equals size, and then I can say that step equals is there a way I say increment incur invalid syntax. Okay, so 6 comma 2, so it should be 0, 3 and 5. Let's try this again. Okay, so range takes no keyword argument. Okay, I don't really understand. Step Okay, if I provide it this thing, okay, right, what will it do? Nothing, because actually size is greater than, so it assumes that this is start and this is stop. Okay, if I go this, hmm, start, okay, stop, then I think I don't really understand this syntax. Let me go range python, range start stop step, right? Iterate from 2 to 6, iterate in reverse, python documentation, r range, the range, okay, yeah, I, okay, reduce, sorry, reduce, this is range. What does this mean? Do you have an example of that? So I can't just provide start plus I into step and stop. Okay, let's continue with thematic progressions. Yes. Okay, so I do need to define a start 0, 5, and then incur. Okay, well then it's really easy. Okay, what happens if you get rid of it? If I say I equal I is 1, what happens? Hmm. Oh, print time. Ah, it will just print, yeah. Okay. So it started with 0, we incremented I. Yep. Okay. Right. Again the range. Okay, so this is the list of 0 to 5 and we are just simply, okay, so range returns returns list of AP is AP. Okay, then we have common student questions. What's the difference between a for loop and while loop? What's the time? Okay, a for loop can only iterate over collection of things. A while loop can do any kind of iteration looping we want. However, while loops are harder to get right, and normally can get many things done with for loops. Loops are hard. How do I figure them out? The main reason people don't understand loop is because they can't follow the jumping that the code does. When a loop runs, it goes through its block of code, and at the end it jumps back to the top. To visualize this, put print statements all over the loop printing out when the loop Python is running, and what the variables are set to at those points. Write print lines before the loop, at the top of the loop, in the middle, and at the bottom. Set the output and try to understand the jumping that's going on. Alright. So if you have accessing elements of list, lists are pretty useful, but unless you can get at the things in them. But unless you can get at the things in them, they aren't all that good. You can already go through the elements of a list in order, but if you want, say, the fifth element, you need to know how to access the elements of a list. Here's how you would access the first element of a list by 0. You take a list of animals, then you get the first using 0. How does that work? Because of the way math works. Python starts its list at 0 rather than 1. It seems weird, but there are many advantages to this, even though it is mostly arbitrary. Okay, the best way to explain why is by showing you the difference between how you use numbers and how programmers use numbers. Imagine you're watching 4 animals in our list: bear, tiger, penguin, zebra, run in a race. They cross the finish line in the order we have them in the list. The race was really exciting because the animals didn't eat each other and somehow managed to run a race. Your friends show up late and wants to know who won. Does your friend say who came in 0th? No, he says who came in first. This is because the order of the animals is important. You can't have second element without the first element, and you can't have third element without the second. It's also impossible to have a 0th animal since 0 means nothing. How can you have nothing win a race? It just doesn't make sense. We call these kinds of numbers ordinal numbers because they indicate an ordering of things. Alright. Programmers, however, can't think this way because they can pick any element out of a list at any point. To programmers, the list of animals is more like a deck of cards. If they want the tiger, they grab it. If they want the zebra, they can take it too. This need to pull elements out of list at random means that they need a way to indicate elements consistently by an address or an index. And the best way to do this is start the indices at 0. Trust me on this, the math is way easier for these kind of accessors. This kind of number is called cardinal number and means you can pick it random. So there needs to be 0 elements. How does this help you work with lists? Okay, simple. Every time you say to yourself, I want the third animal, translate this ordinal number to a cardinal number by subtracting 1. The third animal is at index 2 and is a penguin. You have to do this because you have spent your life using ordinal number and now you have to think in cardinal. Just subtract 1 and you're good. Okay, so we go. Let's practice. Take this list of animals and follow the exercise where I tell you to write down what animal you can get for the ordinal or cardinal number. Remember, if I say first, second, then I'm using ordinal. So subtract 1. If I give you the animal at 1, then use animal at index 1. Okay, then use directly. So animal at 1 is type. Yeah. Animal at 1 is Python 3.6. Third animal is peacock. Okay, take the list and follow the exercise where I tell you to write down what animal you get. Okay, peacock. First animal is bear. One minus, yeah, peacock. Animal at 3 is kangaroo. Animal at 5th is platypus. Animal at 2 is peacock again. The 6th animal is platypus. Animal at 4 is kangaroo. For each of these, write out the full sentence of the form. The first animal is at 0 and is a bear. Okay, first animal. Then say it backwards. The animal at 0 is the first animal and is a bear. Use Python to check your answers. Okay. With what you know of the difference between these types of numbers, can you explain why the year 2010 in January is really 2010 and not 2009? You can't pick years at random. Okay. Write some more lists and work out similar indexes until you can translate them. Use Python to check your answers. Okay. Warning. Programmers will tell you to read this guy named Ditchcaster on this subject. I recommend you avoid his writings of this on this unless you enjoy being yelled at by someone who stopped programming at the same time programming started. Ditchcaster. Okay. Branches and functions. Okay. Exit. Sys. You have learned if statement, functions and lists. Now it's time to bend your mind. Type this in and see if you can figure it out. Okay, so we are going how much you take, if 0 in choice or 1 in choice, how much equals int of choice as dead. Okay, man learned to type a number. There must be a function named dead. Yeah, right. Good job. Exit 0. Okay. What is this exercise? Branches and functions. So 1, 2, I'm on third. Then designing and debugging. Okay. So we're doing good so far. Yeah. Shouldn't be that long. Alright. So we are from sys import exit. Right. So 34. This is called branches and functions. Hey, hold up. I finished. Okay, 30 loops and list. Okay, so 33, 34. Okay, 35. This is 35. Branches and functions. Okay, so let's 35.py. We are from sys. We import exit. And we go def gold room. This room is full of gold. How much do you take? Right. This room is full of gold. How much do you take? Then we have choice. Learn to type a number. Okay, so we take an input with a prompt. Okay. So if 0 in choice or 1 in choice, how much equals integer of choice. Then else dead. Else we call the function dead, and we pass the argument man learn to type a number. Man learn to type a number. Okay. If how much okay. Okay. So checking for character 0 of 1 and in the string choice. Okay. And we have if how much less than 50. Nice. You're not greedy. You win. If how much less than 50. Print nice. You're not greedy. You win. You're not greedy. You win. Else, okay, nice, you're not greedy, you win, and then we set we code 0. Then we dead, you greedy bastard. Okay, then we have a different function bare room. Print there's a bear here. Okay. There's a bear here. Then we have print the bear has a bunch of honey. Has a bunch of honey. We have print the fat bear is in front of another door. The fat bear is in front of another door. Then we have how are you going to move the bear? How are you going to move the bear? We have bear moved equals false. We have while true, choice input take honey. Okay. We have choice and not bear moved. The bear has moved from the door. You can get through. Goes true. Don't bear. Choice equals taunt bear and bear moved. The bear gets pissed off. Okay, so we have a not taunt bear. Choice open door and bear moved. Then we go to as I got no idea what happens now. Okay, so we don't do taunt bear. Okay, then we have bear moved equals true, and then I say okay, so we can't taunt bear twice. Okay, right, then we go to the room. Okay, is it really necessary? Okay, then you call cold room. Cold room is the last one. Cthulhu's room. Okay, well this is calling itself. Start mentioning here in dark room. There's a door and we call start. Okay. Start. There's a cold room. Okay. That was tasty. Do you flee your life or eat your head? Dead by start. Just right, left. Oh, okay. Okay. So we'll get this out of the way real quickly. While true, we have choice. Choice equals input. We have if choice. Equals take honey. Choice equals taking dead. The bear looks at you, the slaps your looks at you, then slaps. Now face off. And we have Aleph choice equals taunt bear and not bear moved. When we print the bear has moved from the floor, you can go through it now. And the bear has moved from the door. You can go through it now. You can go through it now. And we have another if choice equals taunt bear and bear has already moved. Then we go dead, right? The bear gets pissed off and chooses a layer. The bear gets pissed off and choose your leg off. Then we have elf choice equals open doors and bear moved. Then we can say gold to equal to gold room. Else I got no idea what that means. I got no idea what that means. We have Def Cthulhu's room. This is Cthulhu. Room. Then we have here you see the great evil this he did whatever stay that you and go insane. Whatever stares at you and goes insane. Do you flee for your life or eat your head? Do you flee for your life or eat your head? Question mark. Then we have a choice. Then again we do string matching if flee and choice we start and we have elf head. Well, that was tasty. LF head in choice. Choice dead That was tasty. We have else. Lose the same function. Tulu room. Okay. Then we have def dead y. We print y. Good job. And we exit with exit code 0. We have start. Okay. You stumble around the room until you starve. You are in dark room. Because print you are in a dark room. Print there is a door to your right and left. There is a door to your right and left. Which one do you take? Which one do you take? And we take the choice. If left and choice, okay. If choice equals left, and then we have bedroom. Then we have LF. Choice equals right. Then we go to this guy's room. Else we go. You stumble around the room until you starve. Stumble around the room until you start. And then we first call the function start. Let's try and run this. On the left there's a bear. Don't bear, the bear's moved. Open door. Huh. Why would you say if I wrote open door and if I got no idea what that means. Open door. Okay. Oh. Okay. So else choice equals open door. Take honey, don't bear. Open door. Choice. Take the input on choice. I'm checking for choice, but it is okay. If take honey, don't bear, and open door. With the bears moved from the door, you can go to the door. I got no idea what that means. Open door again, and it okay. I have not set bear moved equals true. That was the problem because here change this again. clear. Left, don't bear, open door, I go 40. Nice, I'm not reading it. Okay. Then we have what you should see. Draw a map of the game and how you flow through it. Fix all your mistakes, including spelling mistakes. Write comments for the functions you do not understand. Add more to the game. What can you do to both simplify and expand it? The gold room has a weird way of getting you to type a number. What are all the bugs in this way of doing it? Okay. Can you make it better than what I've written? Look at how int works for clues. Okay. We have common student question. Help, how does this program work? When you get stuck understanding a piece of code, simply write in English. Okay. So okay. So I can say I would say all the string used to have these functions. String, yeah. Okay, there used to be printable punctuation string. Okay, format. Okay, where are the members? Is valid. Okay, is alpha. Sorry, is num. Right? Is there should be a function. It is valid. And there should be a is num. Split. Okay, I get that. And that is all. Huh. All SQL address, lowercase letters. Okay, so this is what it supports. Make reference is valid. You know, where are all the is alpha. Is alpha as alum. I use help string to help on the string class. Okay, Python documentation for us use help to get interactive help utility to. Okay, so can I go Python help on str, right? String, yeah. Okay, where are capitalize your center in code, right? Ends with, then I should, yeah. Is alpha, is alnum, and is key, is decimal string, is digit. Okay. Is numeric, returns string is numeric, false otherwise. String numeric, that there is at least one character and there is at least one. Okay, is numeric. Okay, so I can check is numeric. Okay, so I can say if is this is a member function, right? Okay, if choice dot is decimal, then you can say how much. Okay, so you can implicitly define functions which are available. Scopes are different here. Okay, how much equals int of choice. Oh, then exercise 35. Which one? Left. We go. Don't bear. You can go open door. I can say 50. Okay, so it gets choice is decimal. Okay, string is is okay. So there is now. All right. You go left. You go don't bear. Ah shit. Okay. Go left. Don't bear. Open door and let's say 50. Okay. Yeah, so that works. Okay, and if I go left, don't bear, open door, let's say, and learn to type in. Good job. Okay, great. So help. How does this program work? When you get keep your comments short and similar to code, then either diagram how the code works or write a paragraph describing it. If you do that, you'll get it. Okay. Why did you write while loop? That makes an infinite loop. True. Okay. What does exit 0 do? On many operating systems, the program can abort with exit 0 and the number passed in will indicate an error or not. If you do exit 1, then it will be an error, but exit 0 will be a good exit. The reason is it's backwards from normal Boolean logic. With 0 equals false is that you can use different numbers to indicate different errors. You can do exit 100 for a different error and exit 2 or exit 1. Right, okay. So why is input sometimes written as this? The parameter to the input is a string that should print a prompt. Yeah. Okay. So we have designing and debugging. Now that you know if statements, I'm going to give you some rules for for loops and while loops that will keep you out of trouble. I'm also going to give you some tips on debugging so that you can figure out problems with your program. Finally, you will design a little game similar to the last exercise but with a slight twist. Okay. Rules for if statement. Every if statement must have an else. If this else should never run, if this else should never run because it doesn't make sense, then you must use the die function in the else that prints out an error message and dies, just like we did in the last exercise. This will find many errors. Okay. Never nest if statements more than 2 deep. More than 2 deep, and always try to do them 1 deep. Okay. Treat if statements like paragraphs, where each if else grouping is like a set of sentences. Put blank lines before and after. Your Boolean tests should be simple. If they're complex, move their calculations to variables earlier in function and use a good name for the variable. Okay. If you follow these simple rules, you will start writing better code than most programmers. Go back to the last exercise and see if I followed all these rules. If not, fix my mistakes. Warning. Never be a slave to the rules in real life. For training purposes, you need to follow these rules to make your mind strong, but in real life, sometimes these rules are just stupid. If you think a rule is stupid, try not using it. Rules for loops. Use a while loop only to loop forever, and that means probably never. This only applies to Python. Other languages are different. Okay. So use a for loop for all kinds of things, all kinds of looping, especially if there is a fixed or limited number of things to loop over. Okay. Tips for debugging. Do not use a debugger. A debugger is like doing a full body scan on a sick person. Do not get any specific useful information, and you find a whole lot of information that doesn't help and is just confusing. The best way to debug a program is to use print to print out the values of variables at points in the program to see where they go wrong. Make sure parts of your programs work as you work on them. Do not write massive files of code before you try to run them. Code a little, run a little, fix a little. Okay, homework. So now write a game similar to the one that I created in the last exercise. It can be any kind of game you want in the same flavor. Spend a week on it, making it as interesting as possible. For study details, use lists, functions, and modules as much as possible, and find as many new pieces of Python as you can to make the game work. Before you start coding, you must draw a map for your game. Create rooms, monsters, and traps that player must go through on paper before you code. Okay. Once you have your map, try to code it up. If you try If you find problems with the map, then adjust it and make the code match it. Best way to work on a piece of software is in small chunks. On a sheet of paper or an index card, write a list of tasks you need to complete to finish the software. This is your to-do list. Pick the easiest thing you can do from a list. Write out English comments in a source file as a guide for how you would accomplish this task in your code. Write some of the code in the English comments. Okay. Quickly run a script to see if that code worked. Keep working in a cycle of writing some code, running it to test it, and fixing it until it works. Okay. Cross this task off list, then pick your next easiest. This process will help you work on software in a methodical and consistent manner. As you work, update your list by removing tasks you don't really need and adding the ones you need. Symbol review. Okay, so these are all the symbols. Okay, it's time to review the symbols and Python words you know and pick up a few more for the next few lessons. I have written out all the Python symbols and cards that are important to know. In this lesson, take each keyword and first try to write out what it does from memory. Next, search online for it and see what it really does. This may be difficult because some of these are difficult to search for, but try anyway. If you get one of these wrong from memory, make an index card with a correct definition and try to correct. Okay, if you get one of these wrongs from memory, make an index card with the correct definition and try to correct your memory. Okay, finally, use each of these in a small Python program or as many as you can get done. The goal is to find out what the symbol does. Make sure you got it right. Correct it if you did not, then use it to lock in. Okay, and logical and as part of with x as y. Pass. I said ensure that something is true. Break. Okay. Class, define the class. Okay, then we have continue. Don't process. Okay, do it again. Okay, def mention, delete from dictionary. Elif. Then we have except. Yeah, except try. Okay. We have exec. If an exception happens, do this. Run a string as Python. Finally, exceptions are not. Finally, do this no matter what. Finally, okay. Exception or not. For loop over a collection of things from import specific parts of module. Global, declare that you want to declare a global variable. If import a module in parts of loop is like equal to x and y 1 in 1 2. Okay. Lambda, create a short anonymous function, not logical not or logical or. Pass, the block is empty. With print the string. Raise an exception when things go wrong. Raise value error. And return, exit the function. Try block while we didn't go to map function. Okay, then we have with an expression is variable. as a variable too with x as a y. Okay, try. I think we were opening files in a with statement with file as open and then okay data types. Okay, I think Python should help me with 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 is wrong. As is wrong. Huh. Okay. The with statement. The with statement is used to wrap the execution of a block with methods defined by context manager. See section context manager. This allows common, try, except and finally usage patterns to be encapsulated for convenient reuse. Okay. With the execution of with statement with one item proceeds as follows. Okay, what is it called? Okay. Okay, so we have these data types, new string escapes, old style formats, plus text float number string, bytes, none, true and false. Then we have operators, float division, power assign, multiply assign. This is power off. 2 to the power 4 at decorators, comma, colon, dot, percent. Okay, then we have spend a week on this, but if you finish faster, that's great. The point is to get coverage on all these. Okay. Reading code. Okay. Third, okay. First, print out the code you want to understand. Yes, print it out. Because your eyes and brains are more used to reading paper than computer strings, make sure you print a few pages at a time. Okay. And second, go through your printouts and take notes on the following functions and what they do. Where each variable is first given a value. Any variable with the same name in different parts of the program, these may be trouble data. Any if statements without else clauses are the right. Any while loops that might not end, and any part of the code you can't understand for whatever reason. Third, once you have all this marked up, try to explain it to yourself by writing comments as you go. Explain the functions, how they are used, what variables are involved, and anything you can to figure this code out. Last, on all of the difficult parts, trace the values of each variable line by line, function by function. In fact, do another printout and write in the margin the value of each variable that you need to trace. Once you have a good idea of what the code does, go back to the computer and read it again to see if you find new things. Keep finding more code and doing this until you do not need the printouts anymore. Okay, find out what a flowchart is and draw a few. If you find errors in code, try to fixing them and send all your changes. Another technique for when you are not using paper is to put comments with your notes in the code. Sometimes these could become the actual comments to help next person. We have doing things to list. Okay, that's it. And